Good morning from sunny Los Angeles, California. My name is Zoltan Peristegui, and I'm the Vice President of Product Development at RotaChrome North America, and I'll be your host for today. Let me say a couple of words about RotaChrome before we start. RotaChrome is the inventor and only producer in the world of automated industrial-scale centrifugal partition chromatography instruments. And centrifugal partition chromatography will be referred to as CPC in today's session. Established in 2014 in Europe, RotaChrome has presence in North America, Asia, and Europe with applications in the pharmaceutical, natural extracts, food and beverages, and cosmetics and fragrances industries. One of our major applications in the US is in the hemp and cannabis processing field. We're supported by a local team of professionals like Kelly Peterson, who is our Director of Technical Services at RotaChrome North America, and who will be holding our webinar this morning or afternoon, depending on your location. A couple of housekeeping notes, and then I'll hand over straight to Kelly. Your cameras are off and microphones are muted throughout this session, but you'll find a Q&A button at the bottom of your screen. If you have questions, please add them there, and we'll try to answer as many as we can at the end of today's session. We'll follow up one-on-one with every participant who asks questions that we won't have time to answer today. And with that, let's now head over to Denver, Colorado.
Thank you, Zoltan. Greetings from the Rocky Mountains. Welcome to the introduction to RotaChrom's Centrifugal Partition Chromatography Solutions webinar. My name is Kelly Peterson, and I am the Director of Technical Services for RotaChrome North America. I come from the world of analytical chemistry. Formerly, I was the groundwater chemist for the state of Colorado, and also electromechanical engineering, where I worked for a prominent manufacturer of laboratory instruments focused on mass spectrometry. Today, we're going to review centrifugal partition chromatography technology, the RotaChrome CPC platforms, and CPC solutions for the hemp industry. CPC can provide CBD isolation, THC remediation, CBD minors isolation, and pesticide removal. CPC is a liquid-liquid separation technique. Liquid-liquid separations work by leveraging a compound's partition preference for one liquid phase or the other. This is based upon a compound of interest partition coefficient. In CPC, the chromatographic column is made up of cells on the rotor. These cells are interconnected by tubing, and therefore column capacity can be scaled up by increasing the number and size of the cells. CPC offers high precision, as every run is performed with refreshed stationary phase. Precision, which describes the degree of agreement of individual samples run under the same conditions using the same equipment. It is adaptable and refinable, as the solvent system can be changed and optimized. And it is cost effective, as both the stationary phase and mobile phase solvents can be recycled and reused. CPC affects separations by utilizing two immiscible liquid phases, introduction of compounds of interest to the system via the mobile phase, and leveraging a compound's partition preference for one liquid phase or the other. This is called a compound of interest partition coefficient. In CPC, the stationary phase is immobilized inside the rotor using centrifugal force. The sample is dissolved in the mobile phase and is introduced under pressure to the rotor and pumped through the stationary phase in the form of tiny droplets. This is also called percolation. This is a simple and reproducible mechanism that leverages compounds' partition coefficients. The RotaChrome CPC technology has several advantages and provides better return on investment compared to alternative technologies. It offers moderate solvent consumption due to the ability to recycle the solvent separation system, has high capacity and loadability, A high degree of flexibility as solvent systems can be readily changed or modified. Consider the challenges when looking to improve or modify the solvent system. Separation using traditional solid phase column chromatography. CPC is superior in this regard. Now let's dive into the chemistry a little bit. The partition coefficient is the ratio of concentrations of a compound in a mixture of two immiscible solvents at equilibrium. This ratio is therefore a comparison of the solubilities of the solute in these two liquid phases. The CPC chromatogram demonstrates the separation of compounds of interest based on their unique partition coefficients achieved through a centrifugal partition chromatography system. So as we review the slide on the left here, we can see samples introduced to the beaker where we have two different solvents, the upper and lower phase. And moving to the right beaker, we see the analytes separate into the two solvent systems based on their partition coefficient. The core advantages of CPC include it's highly flexible. We do not see irreversible absorption. We have no expensive and variable stationary phase. Nearly total sample recovery. High loadability. Easy scale up. And it is quite versatile, lends itself well to experimenting with the chemistry of the process. And don't forget, solvents used in CPC can be recycled and reused, an important and sustainable effort. RotaChrome offers two types of CPC in two different sizes. The RCPC, you see that on the left, is our smallest scale platform, and the R stands for research. This pilot scale instrument is designed to demonstrate proof of concept, perform small scale production, and to develop and optimize biphasic solvent systems for specific purification projects. The RCPC platform is capable of processing between 100 to 300 grams of input material per hour. Loading capacity is dependent upon the compounds of interest and corresponding method. There is a balance sought between purity, throughput, and yield. Now we move on to the ICPC. The PCPC system is comprised of industrial scale auxiliary skids and an ICPC, which you see in the foreground next to the person. The P stands for production, and it is a PLC controlled, fully automated platform capable of industrial scale solvent preparation, solvent recycling, and recirculation. PLC stands for Programmable Logic Controller. The instrument is designed for continuous batch processing and to maximize efficiency and production capacity. The PCPC is capable of processing anywhere between 1 to 3 kilograms per hour, depending on the crude input material and purification project goals. This slide demonstrates a possible PCPC layout, showing the auxiliary skids, the ICPC, in C1D2 certified rooms. The system control units are located outside of the C1D2 certified rooms. In a C1D2 location, volatile flammable liquids or gases are used but are normally confined in closed containers, such as 55-gallon drums, or closed systems, such as the PCPC system. It also may be a place where ignitable concentrations of gases or vapors are prevented with positive mechanical ventilation. The PCPC system consists of 6 major components, 5 auxiliary skids, and the PLC, which you see in the lower right of the slide. Next, we're going to break down each of these elements and describe them in a little more detail. The mixer settler skid, in the upper left, is designed for solvent preparation and maintains the desired solvent ratio for the method in use. The goal with the mixer settler is to manage solvent ratios for optimal separation of the compounds of interest. The input buffer skid, you see in the lower left, stores the mixed solvents in two large tanks and includes the sample introduction tank. These tanks feed the industrial ICPC, where compounds are separated. The fraction collector, which you see in the upper row in the middle, stores up to 9 isolated fractions, which are captured from the ICPC in automated fashion. The output or impurity, sometimes called the waste skid, upper right corner in the top row, function of this skid is to store the flow streams from the ICPC, both the upper and lower phases, that do not contain significant amounts of compounds of interest. This is in preparation for recycling used solvents back into the PCPC process. The evaporator skid, seen in the middle in the lower row, functions to recycle the solvent mixtures stored in the impurity or COI skids. Finally, we have the control unit, or PLC. Again, that is a programmable logic controller that retains operational firmware, programmable parameters, sensors and detectors, and a touchscreen user interface. Here, we see an example of the touchscreen user interface. Notice it has controllable interactive sensors, valves, and pumps, each with their own specific logo or indicator. This is a glimpse of where a daily operator would control the PCPC system. RotaChrome technology can purify large industrial-scale batches of hemp-derived products with near continuous automated operation. Now we move into an example of an output UV chromatogram from an example RCPC or ICPC loop. Note the isolation of CBD in the center. THC removal could be seen on the far right, and minor cannabinoid isolation is demonstrated throughout the chromatogram. Now we bring in fraction collection relative to the CPC method loop. Note the blue lines throughout the CBD fraction. This is CBD isolation, demonstrating fraction capture timing optimized to purely CBD. Moving forward, we see a method with different fraction capture timing. Here we've optimized to capture all CBD and minor cannabinoids while separating and removing THC from sellable fractions. Our last example, we're demonstrating a fraction capture timing set up for isolating groups of minor cannabinoids in bulk fashion. This is very useful because it allows us to build up amounts of smaller yield, highly profitable minors for batch processing through the RCPC or ICPC system later on. CPC can also be used for pesticide removal. I'm very proud that my colleagues presented their research results at the American Chemical Society's national meeting earlier this year. You can hear more detail about their work in our future webinar. We understand the investment in hemp separation and purification technology. RotaChrome works closely with customers through all phases of planning and acquisition, implementation, ongoing operation and maintenance, training, and method development. Our scope expands beyond the CPC equipment to your success. In summary, CPC is a liquid-liquid chromatographic technique. It has multiple benefits, it's easy to scale up, and provides a rapid return on investment. The PCPC system offers automated continuous biphasic solvent system preparation, and when it is optimized, it is feasible to run in an automated fashion with near continuous operation. Key uses include isolation of various cannabinoids, removal of THC, and remediation of pesticides. I'd like to thank you for spending time with us here at RotaChrome today, and our question session will now open. With that, I turn it back over to Zoltan.
Thank you, Kelly. Let's see. While I look through the questions, I actually would like to draw your attention to our upcoming webinar, which will be held by András Gáspár, PhD, a senior scientist on RotaChrom's team, who will be talking about technology and investment considerations for industrial scale purification. It surely will be a very exciting session with lots of insights and details, including comparisons of the different legacy and innovative purification options. So save your seat now to ensure you won't miss this opportunity, and head over to bit.ly, that's bit.ly/RotaChrome webinar to register now. And now let's see the questions. A participant is asking about the quantity of CBD. So how much CBD can I isolate with your large scale machine per month is the question.
Okay, I can field that. When we look at the ICPC, we noted that we can produce about 1 to 3 kilograms per hour. So if we look at a typical month, 24 hours a day, 30 days in the month, the math tells us that we have about 720 hours available for operation. I like to subtract about 15% from that time to allow for maintenance, sample transfer, and solvent management. That brings us down to 612 hours of operational time per month. We'll just round that to 600. Taking that back to our 1 to 3 kilograms per hour, we could expect approximately 600 to 1,800 kilograms per month. Again, it is dependent upon the condition of the crude isolate with which we begin with, and also the purification goals. Zoltan?
That sounds impressive, Kelly. Thank you for answering that question. Next question is asking, our next participant is asking about the possibility to elute THC rather than CBD first. Is that an option on our RotaChrom's purification platform?
Thank you, Zoltan. That is a somewhat complicated chemistry question, so I'm going to answer generally, but we will circle back with you and get more specific. So separations are affected by the choice of solvent system. It is conceivable that we could design and implement a solvent system that would change the elution order of THC and CBD and allow THC to elute first. Again, that requires chemists' involvement in optimizing a method and some troubleshooting to work it all out. The way RotaChrome operates now, we typically see CBD elution before THC. But due to the flexibility of the CPC technology, it is possible to change that with a different solvent system. Zoltan?
Thank you, Kelly. Next participant is asking about actually having the option to see a working system. So the specific question is, I've seen these presentations from other companies, and they're usually just great PowerPoint decks. Can I actually see a working system somewhere in the US? So do we have a working system is the question.
The answer to that is yes. We have agreements with current system owners, and new customers can visit and tour their facilities after signing an NDA.
Thank you. The following question is about zoning requirements for the CPC systems, specifically about the research scale, so the RCPC system, whether that needs to be placed in a C1D1 environment?
The answer to that is no, it does not have to be placed in a C1D1 or C1D2 environment. And that's due to the volumes of flammable solvents used. They do not exceed typical fire codes. Now, that said, the PCPC system does require C1D1 or C1D2 classified rooms due to the flammable solvent volumes in most jurisdictions. RotaChrome recommends that customers become familiar with local building codes in the location where they intend to operate. And just to review, C1D1 represents hazardous gas that is present during normal operations and work conditions. C1D2 means hazardous gases are present, but they typically remain in a container, like a 55-gallon drum, or in a system under normal circumstances. Zoltan?
Thank you, Kelly. I will jump in and answer the following question, actually, or the next question. There are two questions asking about the cost of our systems, specifically the RCPC and the ICPC. And while we don't publish our pricing up front, we're very happy to understand the situation and the requirements of you as a customer. As Kelly mentioned during the presentation, we offer way more than just selling you a system. So we offer you a solution for your purification needs, which includes anything from method development, feasibility studies, training, on-site installations, and even consultancy during the build out of your facility. So we're very happy to work with you. And two figures that I can share, though, is that the small scale system is in the 6-digit range, while the large scale system, the ICPC and the PCPC, would fall under the 7-digit range in USD terms. The following question is about solvent volumes. I will turn to Kelly to answer this. The specific question is about solvent volumes for the RCPC and the ICPC. So if, Kelly, you can share the approximate range of solvents being used, that would be very helpful.
Sure. So I'm going to answer this very generally because solvent volumes are highly method specific. So when we're talking about the RCPC, the smaller unit, we're typically working in the liters range with regard to solvent. And when we move up to the ICPC, we typically see solvents stored in 55-gallon drums near the ICPC. Again, it's a general response because it's highly specific. If you want more detailed information, we're happy to circle back and discuss that with you. Zoltan?
Talking about solvents, volumes of solvents, thank you for answering that. There's also a question about which solvents or what solvent systems are generally being used on our CPC platforms. Kelly, can you give us or shed some light for us on that?
Sure. I noticed they're questioning if they are organic solvents. Indeed, they are. For the cannabinoid separation and purification, we typically see hexane, methanol, and DI water used. Zoltan?
Thank you for that. And the last question that we can take live now on our webinar will be about having a representative on the ground in Mexico, and I will jump in and answer that question. So while we do not have anybody on the ground in Mexico, our North America team is very happy to work with you and we also cover the Mexican market. So we will be in touch with you to discuss your specific needs and see how we support your purification requirements. So that concludes our Q&A sessions. Thank you very much, Kelly, for answering all those questions. Thank you once again to all the attendees for your time. I hope you found our session very useful. We will send you a link to view the replay of today's session shortly if you missed some parts of it or you would just like to listen to it once again. Please don't hesitate to reach us at sales@rotachrom.com. That's sales@rotachrom.com. Should you have any questions or would be interested in learning more about our purification platform. Please stay safe during the holidays, and I hope to see you again on January 14th on our deep dive session. Don't forget to register for this session now at bit.ly, that's bit.ly/RotaChrome webinar. That's the address, and we'll see you next year. Thank you.